just the title, because. All right, so we're going to talk about multiplying binomials and factoring difference of squares today. Once again, this is a review unit. We're just kind of like prepping your guys' brains for our next topics we'll be getting to later. This is review stuff from Algebra 1 that we can all use a little brusher up with. All right. I'm going to start off with an example here. So, yeah. Yeah. I'm going to write down this stuff here. So, how many of you guys, while you're writing, raise your left hand if you write with your right hand? How many of you guys had Mr. Matthews last year? 1, 2, 3, 4. How many of you guys had, who else taught Algebra 1?
And,
how many of you guys had Lahan?
I think
how many of you guys had Chu?
Oh, you guys lame.
Is there any other Algebra 1 teachers I'm missing here?
Is it Mr. Hine?
Who?
Mr.
Hine.
Oh, yeah,
Did you have Hine? Who'd you have? Oh, okay, Mr. McWhirter. So we had Hine. Yes?
That's funny. You're not even talking. You're just like.
Oh, because I wasn't an algebra.
So we have a pretty even spread in here. So I'm asking because the way that you guys learn this stuff could have been different for each teacher. So I'm going to show you the way that I do it since it's kind of evenly spread. And I think most teachers do this anyway. But the way I do it, I like because we're going to do two things. We're going to multiply these, right?
Wait, do we need that?
This is just foil, right?
But afterwards, we're eventually going to learn how to work backwards. So we're going to start with an unmultiplied. We're going to multiply together. But you also need to know how to go backwards. That's called factoring, where you have that answer. You got to undo it so it looks multiplied again. And the way that I teach my multiplying works really well with the going backwards approach as well. So I'm going to stick with that. But how many of you guys have heard of FOIL? So FOIL will work for today. That is not what I will be doing. It's really the same thing. Yeah. Don't worry about it. I'm not going to do it. I'm going to use the box method. How many of you guys know the box method?
I don't. I don't even know what
Not
this is.
very many.
I do.
Okay. Interesting. Maybe the box is losing popularity.
Wait, the box as in like this?
So if you guys are comfortable,
Wait, this?
if you guys are comfortable with the, no, well, it's close to that. That's part of it. But anyway, if you guys are comfortable with FOIL and you'd rather do that, I'm okay with it. Just make sure you're getting the right answer. That's all that I care.
Okay, quick question.
Here we
Can
go.
you explain, like, I'm a visual learner, what is FOIL and what is box?
I don't want to talk about FOIL, but I'm going to show you box. So everybody draw a box. Everybody draw a box. Everybody draw a box. What? Now, here's what you're going to do. You're going to put the first one along the top, x plus 3.
Oh, I didn't know what it was.
I find this one easier. I learned this too. I learned this
It's really just the same thing as FOIL. You're just showing your work differently.
Hang on.
Biology, what is that?
This one,
Wait,
yeah, it's like a
you
Punnett
need it
square.
Yeah.
This one you're going to put down the side. So for instance, 2x minus 1. So you've got x plus 3 along the top and 2x minus 1 on the side. And what we're going to do is we're going to multiply to fill in the box. Now you guys should know how to do this because we did multiplication yesterday. Here's what you do. To fill in this blank, you look at the term above it and to the left of it. What is x times 2x? Okay. For this one, you're going to look at the one above it and to the one all the way over here to the right. What would that be? Okay, I would like you guys to see if you can fill in these ones. You're going to do that times that to fill in this box, and for this box, it's that top times that side. See if you can fill them in.
So basically, like the side by the top.
Yeah, exactly.
Wait, what? For 3, which one do I? 1?
For this box, you'll do 3 times negative 1. Yeah, that's fine. All right. So let me put these away. This is for my last block. Okay, so I'm going to ask, moment of silence for Raquel. She left us. All right, let's try Henry. Henry, what goes here?
Negative x.
Yep. Because -1 times x is negative x. You could say -1x if you want. That's fine. And let's do Patrick. What goes here? You're gonna multiply these. There you go. -3. Okay. Now what we're gonna do is we're gonna combine. We're gonna take all these things out. But before we do, you want to combine your like terms. Your like terms are always diagonal from each other. So we have 2x squared, right? And what is 6 take away 1? So that's going to end up being 5x. Those two combine together to make 5x.
What happens if instead of writing no more negative x, we wrote
That's fine. Yep. So I'll say this again. You guys ready? The top left comes first. The bottom right comes last. You combine these two together for the middle.
Alright.
Okay? Let's do another one. Sure.
Wait, what? How'd you get a positive 5?
Because 6 we're going to combine these, right?
Oh.
And 6 take away 1 is 5.
Oh. Okay, and then
Wait. What the? I was thinking, what?
and then you just bring down everything else.
All right, let's do another one. X minus 2 times x plus 4. Is ready?
No, hang on.
I'm going to call on you for this one.
When was this box invented?
I don't know. That's a good question. Okay, so I'm going to ask Kayla. What goes up here?
Does it depend where you put it?
Good. Then I'm going to ask Natalie. What goes over here, Kayla?
X.
I'm going to put plus 4, but 4 would be fine. All right. I'm going to call on someone else now. Javier? Closer. Here's why. Because my coefficients are 1, right? And so are my exponents. And when you multiply monomials, you multiply the coefficients. So the coefficient's still 1. 1 times 1 is 1. And then you add the exponents. 1 plus 1 is 2. So it's actually going to be x squared. Let's go ahead and do next one. Rowan, what'd you get for this box over here? True. And Alexis. Where did I put you, Alexis? Is he here today? Oh. I'm still getting used to our new seats. Let's try Kiana. Danielle, what goes here?
4x.
True. And then next, Hannah, what goes here? No.
Wait. Oh.
Multiply.
Wait, so can we
Yes, it will. Okay, now we're going to have 3 numbers. Boom, boom, and boom. Here we go. I'm going to ask Heidi, which one goes here? Good. The top right number goes here. All right? Let's do another one. How about Nathaniel? What number goes here?
All the way to the back?
Yeah,
-8.
good, because the bottom right number goes there.
You said it's okay if we put 1 for the x?
Yeah, that's fine. Yep. All right. And Joanne, you get the interesting one. What goes in the middle?
Oh,
2x. Here's why. Because you combine these like terms.
That's what's gonna be positive.
Because 4 take away 2 is positive 2, right?
Oh yes.
All right. So it looks to me like you guys got it. Yeah, dude? No, because when you combine like terms, so this is what's confusing about this, is that we're doing 2 things. We are multiplying and we're adding. So you got to keep those rules separate. when you multiply the coefficients and you add the exponents. But when you add, all you do is add the coefficients, but you don't touch the exponents. So you got to keep those rules separate. Okay, let me throw a student practice at you. Now this is one where you guys can do it completely on your own. I'm going to say 2x plus 3 times x minus 2. SP1. Go for it. All right, so let me call on somebody, see what you guys got. Kenneth, what did you get, buddy?
For the answer,
Yeah.
2x minus 2.
Could you
You're
just
good.
write 1x?
Oh,
I don't know if did you ever square? Yeah, you want to have that. Everything else is good though.
I'm sorry, I'm bad at explaining.
I'll show my work here. Oh, this is supposed to be a 2, huh? Okay, so any questions about that one?
Wait.
How do you ask questions now?
All right. So
Because I'm bad at explaining.
all we have to do is bring down the so okay. So like every time.
That's going to be the middle? Yeah.
Yeah.
Those two, yeah.
Okay,
What if those have
they could.
like different exponents?
Then they wouldn't be able to be combined. That's a good question.
Oh, so
I don't plan on giving you anything like that right now, but that could happen.
But what if
so what would you do?
You wouldn't be able to combine them, and so what you would do is just put all 4 answers out there, and that's it. So Patrick was asking, what if these weren't actually like terms on the diagonal? Well, that can happen. I won't be giving you anything like that, but if it did happen, you would just not be able to combine them, and you would have 4 pieces instead of 3. That's all. Okay. So I want to give you guys something else here. Let's do this. X minus 2 times x plus 2. Okay? Yeah.
student practice 2?
No, well, this is not a student practice. This is like a,
Student practice B. 1B.
we'll call this a demonstration.
Oh, that's a first.
I know.
You know, I'm putting S.
Demo. Okay, so check this out. Now, what's unique about this situation is that they're the same except one's a plus and one's a minus, right? That causes something interesting to happen that I want you guys to observe. So here we go. Let's do our box.
Oh, wait. Yeah,
Are you gonna let us do it by ourselves first?
I'm gonna go ahead and do it because I know you guys can handle it. I want to get to the interesting thing here. So here we go. Sure, I'll pause a minute. Are we caught up?
No.
I see what you're talking
Now
about.
you guys are working ahead. I told you not.
Hang on, I'm not even ready. Too bad.
So x times x is
1x squared.
x times negative 2 is,
-2.
and 2 times x is, and then 2 times negative 2 is
-1.
negative 4.
Oh.
Now, you're going to put your x squared here, right? You're going to put your negative 4 here. The middle is these combined, but what do you notice there? They cancel because it's the same number but opposite
So
signs
you're just
because
gonna put
of
a 0?
this. So we don't put anything. So your answer is that. Now,
Okay.
here's the thing. I'm going to give you guys a new math rule because actually we don't need to do all this work when we have this set up. Here's your math rule. You ready?
If you see that, then you can legit just like.
Yes, you can skip steps. So check it out. If you have x minus a times x plus a,
You could just.
here's what you're going to get. All you have to do is do x times x. What's that? And a times negative a. What's that?
Hey,
Wait, what the heck just happened?
I'll demonstrate it again, but write it
oh, I
down.
get it. I get it.
So we don't have to do the box. The reason we don't have to do the box is because the middle numbers cancel out anyway. So all you really have to do is multiply the 2 first numbers together and the 2 last numbers together, and you've got your final answer. Yeah. Because it's always going to be a minus, because a negative times a positive will be a minus. Okay? So, but that's just for this special situation where you have x minus a number and then x plus the same number. So let me do a demonstration for you. It's a what it is a shortcut.
Because x times x.
What's
x
a times a?
Oh my god.
Yeah, but on the actual problem, it just says -4.
That's right. So let's take a look at this. Ready? I'm going to delete all this stuff because I told you we don't need it, right?
That's your rate.
So I'm going to get rid of it. Now, what is x times x?
X squared.
And what is negative 2 times positive 2? Negative 4. I can't do that over here because I'm working with a letter. But it's a number. Okay? So the point here is your two first numbers multiplied together, your two last numbers multiplied together. You're good. That only works if you have that situation, though. So don't do that with other problems. You'll get the wrong answer. Okay? So let's go ahead and do example 2 here. Ready? So we're gonna say use the shortcut. Ready? Use the shortcut. So let's say that I have x minus 4 times x plus 4. Does that fit the right pattern? It does, right? Okay, so what is x times x? X squared. What is negative 4 times positive 4? We're done. A lot easier than the box.
Can you only use the shortcut when the numbers are the same?
Yes, so only when they're the same and opposite signs.
So I only wish for reciprocals and the opposite sign.
No reciprocals,
Or
but
like-
same number, opposite signs.
If it was the same number, we have to do box method.
You could do box method, you still get the right answer. It's just more work.
No.
All right, let's do another one.
Hang on.
Listen,
All right.
Bailey, I'm gonna tell you, you're probably my only math teacher that actually paid attention to this one.
Okay, buddy.
Because in algebra, but
He said, okay.
no, what?
Okay, here we go.
He's a soft.
Hang on, I was making a note for myself. Okay, I think you
So, Jonathan, you get to prove that you're paying attention to me now.
He's gonna be like, no, but
What do I write first? What do I do first, Jonathan?
You're going to multiply 2x squared.
Very good. And what would we get if I got that?
4x squared.
Very good.
What do I number this?
Yes.
Let's call this A. We'll call this B.
just call it yes and no, whatever.
Chris, what do I do next?
Multiply the 3 times -3.
And what will that be? We're done.
Wait.
Dang, that's some fast work.
It is fast. All right, you guys ready for student practice?
No, I'm not ready yet. Wait,
Of just these questions.
wait.
I bet you you'll pass.
If we don't,
All right, student practice, ready? I'm going to give you 3 because they're fast. There's no reason you guys can't do this quick, right?
Chill.
I'm going to give you 3.
Wait, what is this for? Student practice two?
This is
Yeah.
student practice 2. Okay, go. Give me 3.
They give us 3 problems.
Wait, so are we?
Don't do it. Don't. I know, don't.
Mr. Bailey, we're gonna fight.
I don't know what I'm doing.
I don't like that third
This is
problem.
multiplying,
We're
right?
using the shortcut.
The third
Alright.
problem, you lied to us.
Trust yourself.
Don't ever trust yourself.
Probably not a bad
No one else here.
We're all human.
You're here to the day.
What's going on?
The third one's different.
Someone's gonna make this day.
oh,
It's not trickery.
you guys can't tell.
Mr. Bean, you made a mistake.
You're right. Something is funny.
It's different here.
Something's wrong, right? So. Yes.
Mr. Bailey, we are
the numbers.
Did I do this? Uh-oh.
Go ahead and try those two. And the third one.
Mr. Bailey?
Good. I like your first two. Now that I've tortured you guys,
Wait,
Vanessa was very emphatic about something earlier.
Look at this.
I'll tell you now.
did I do this right?
Something's wrong with one of those, right? Do you guys see it?
Yeah.
What's the problem?
Well, okay, I'm just gonna change the negative.
Well, they're both positive. Can we use the shortcut when they're both positive?
So you want us to make the whole box?
You have to do the box method.
Mr. Bailey?
I got
Mr. Bailey,
You have to do the box method on that one. If you don't do the box method on that one, you won't get it right. Because one of those is not the shortcut pattern, right? Let me see Nathaniel. Nice. Look at you.
I don't know if I get this.
I did mine
So check your answers with a neighbor. I'm going to give you like another minute here.
This box is wrong.
Yeah, you're good. I think it's negative. Is it? No, it's positive. Better, yes. Yes. Coming along. Good. Good enough. Okay.
Hang on.
Wait. Oh, yeah.
Wait. Oh, right.
Other than that. All right, here we go. I'm going to ask Kendall Coy. What did you get for the first one?
X squared minus
Okay. This one, the shortcut applies. We have a -1 and a +1, so x times x and -1 times 1, and we're good. Shortcut works. We're happy. Next one, Leslie. What did you get for the second one? X squared minus 25. The shortcut applies again because we have -5 plus 5. So x times x is x squared. -5 times 5 is -25. And Annie, you were out to the restroom, so you probably didn't get a chance to get 3 yet, right? Okay. Let's try Paris. What did you get for number? Well, you were gone yesterday. So I don't know. Let's see how you do it. Did you get number 3, the third one? Did you get it? I'll give you a point if you tell me your answer. You don't have to be right. You didn't get to it. Okay, that's all right. You were gone yesterday, so there was some stuff we learned that would make that helpful. But Michael, what did you get for the last one here?
I got it.
X squared plus 8x plus 16.
Okay, so this one is not the shortcut. You have to do the box because it's not the proper pattern.
No, it's
So, what?
that you literally explained the third one to us in the first example, and just like that, everyone forgot about it. Everyone thanked us.
It's because I tricked you. I made it look like these. So I did that on purpose because I want you guys to stay awake and watch out. You can only do the shortcut if you have the pattern. Okay, so don't get cozy with that, but have it as a nice tool. But don't think, ah, my life's solved. It's not true. You've got to make sure the pattern applies. Yeah. No, you can just, if you want us to stay safe and always go box way, you can. You can. Yeah.
No, you're also, I'm looking at number 3. When they have the same number but they add the same sign, I think they come up with another shortcut.
There is another shortcut.
You literally just add and multiply the numbers and you get what
Use it. That's
I was saying that, I
100%
was thinking
correct.
about that, I was like, wait.
That's 100% correct. Now, if I were to put another number in the front, though, that's going to ruin your trick.
Then
But
you'd be screwed.
your trick is a good one for if it's just X. But that's a good pattern. You're right, because they actually have a rule for that one. But I'm not going to bother with it right now. All right, last thing I want to talk to you guys about is unfactoring these things. So here we go. Example 3. Now I'm just going to give you one because I think some of you guys know how to do this already. even though I haven't even showed it to you yet. 1, because it's kind of intuitively graspable anyway. Second, you've already seen it in Algebra 1, so it's possible you already get it. So I just want to throw in at you. Here we go. So Danielle was in class. I gave her a problem, and she got this as an answer. What was her problem? See if you can figure it out. There you go. That's it. That's what we call a difference. This is called a difference of squares. So let's write that down. This is called factoring a difference of squares. This is called factoring a difference of squares. Now I want you guys to know what this vocabulary means though, okay? So first of all, what does factoring mean? It means to unmultiply. So whenever you take an expression like this and you split it apart, that's factoring. That's unmultiplying it, right? So we've done this problem in 2 ways. One way we did today is that we started like this, right? And we multiplied to get 4x squared minus 36. But now we're working backwards. We start with 4x squared minus 36, we break it apart. So 1 is multiplying, and then when you unmultiply it, we call that factoring. Now, why do they call these a difference of squares? Because every time you have one of these problems, you have a difference of 2 numbers that are perfect square roots. Okay? So here's a warning. You guys ready? You might want to write this down. Gotta watch out for these. Do you guys see why this is not a difference of squares? Why not? Yeah, the signs, right? Since there's a plus here, that's not, if you were to split this apart,
Oh, so it needs to be a negative?
it has to be a negative. That's why they call it a difference of squares. If you were to split this apart, right, then if I put it back together, it should give me that, right?
No.
So let's see. If I did, I would get x squared, and what would I get?
Negative 3.
So that's not the same thing. So anytime you have a plus here, you're done. You cannot factor that. This is actually what we call a prime number. You guys know what prime numbers are, right?
Yes.
Prime is where you can't split it apart into something like 3. What are you going to do? 3 times 1? It's the same thing, right? Well, polynomials work the same way. If you can't split them apart, they're called prime. So this is a prime polynomial. You cannot factor it. It is not a difference of squares. Yeah. Like this? Okay, it's actually not. Let me tell you why. You ready? So Vanessa was hypothesizing maybe if we factored it this. Now, do you guys realize that that means this? Like when you square something, you're just multiplying it by itself, right? Can I use the shortcut? No, because they're the
But you
same.
can do what I said, and you can add them first.
You're right. What would it be, John?
It would be x squared plus 10 plus 25.
Beautiful. Nice. Is that the same thing? So, no, it doesn't work either. So this is actually a prime polynomial. You
So we did
cannot
that, where we
factor it. For this,
Wait, we see that, yeah.
you would just say can't factor, or you would say it's prime or something like that. I don't plan on torturing you with that too much, but I do want you guys to be aware of it. So just know that it has to be a difference of squares to actually work. Okay? So,